Now I'm going to introduce you to the idea of acids and bases in their relationship to the molecular orbital diagram, the picture, right? So far, we've looked at a system where both atoms contribute one electron, right? So hydrogen, you have two hydrogen atoms coming together, each has one electron. In general, and in most of organic reactions, we don't have one electron. We have one molecule that contributes both electrons to an empty orbital of another molecule, right? And we have terms that are associated with this. Now, in general chemistry, we learn one of those terms, and that is the idea of Lewis acids and bases. And we learn that a Lewis base is a 2-electron donor, and a Lewis acid is a 2-electron acceptor. And so this is something that, it's mentioned in general chemistry. We don't explore it in great detail, but that's the nuts and bolts of Lewis acid base chemistry. Lewis base donates 2 electrons, Lewis acid accepts 2 electrons. The Lewis base is the molecule that has both electrons, and the Lewis acid has an empty orbital in which it can accept those 2 electrons. Now, oftentimes in organic chemistry, we will refer to Lewis bases in a different context, and we call them nucleophiles. And we call Lewis acids electrophiles. Where do these terms come from? A nucleophile is seeking a nucleus, right? So bases donate 2 electrons. What do they donate to? They donate to a nucleus. They donate to an atom, right? And therefore they are seeking, they are nucleus loving, right? Whereas Lewis acids are electrophiles. They are seeking out electrons to accept, right? So a Lewis base is also a nucleophile. A Lewis acid is also an electrophile. And the quicker you can get that concept down, the easier it's going to be. Now, how does this relate to the picture of a molecular orbital? Well, instead of having, 2 hydrogen atoms coming together, let's envision having a Lewis base orbital and a Lewis acid orbital coming together. Now, in our picture, we have 2 electrons in the Lewis base orbital, and the Lewis acid orbital is empty. What's going to happen? Again, when you mix 2 orbitals, the result is 2 new molecular orbitals. And so we end up with Phi bonding and Phi antibonding, right? A bonding orbital and an antibonding orbital. And again, when we go to fill those molecular orbitals, we have 2 electrons, so both electrons are going to go into the new bonding orbital, right? Notice also that the result is similar to when 2 hydrogen atoms come together. It's just that the electrons are being supplied by only one of the atoms versus both of them, right? Also notice that just like hydrogen, there is a net stabilization. And that stabilization is from the difference between the atomic orbitals and the resulting molecular orbital, right? So that is where the stabilization comes in, which often drives the reactivity of a particular, of 2 things coming together. Remember, generally speaking, unless you add a lot of heat to something or a lot of energy to something, in terms of a spontaneous reaction, there has to be a driving force for that to occur. We're going to explore a lot of Lewis acid-base chemistry in the following chapters.